Welcome, Trekkies, to the first edition of this new series, All Fi, No Sci. Check out my ready room. In the Voyager episode The 37s, the crew encounters a truck from 1930s Earth floating in space. They beam it into the cargo bay and Paris fires it up. Today, we're going to look at three things from this scene. After 4 centuries, would the battery even have enough charge to fire it up? Would the gasoline be stale? And what about the SOS signal they pick up on the truck's AM radio? Is it actually capable of picking up a clear transmission like that? Let's put the psi back in phi and find out. Let's start with the gasoline, because it also gives us some clue to the battery. Normally, here on Earth, gasoline has a shelf life of less than a year, partly due to oxidation. Since gasoline makes a poor rocket fuel, there isn't a lot of practical observation data on what happens to it in space. But some chemists over on Reddit have helped come up with great theories using practical science. Please take all of this with a grain of salt, though, because it's all gathered from folks on the internet, and I've left a link below to the primary thread where all of this has been discussed. One thing that most people agree on is the gas wouldn't be useful after 400 years, with varying opinions on why. One theory proposed by Reddit user Indemnity4 has to do with something called free radical polymerization. Basically, the way gasoline is produced out of crude oil creates inherently unstable free radical molecules. Over time, these grow into long polymer chains that turn the gas into a gel. Even here on Earth, it's another part of the equation as to why gas goes stale. While the coldness of space would slow the process down, over 400 years, it would still be enough to make it useless. The other major point, first proposed by Reddit user KBeta, that was made about gasoline has to do with vapor pressure. Gasoline has a high vapor pressure, which basically means it has its gaseous form in a container with it, and will evaporate faster than liquids with lower vapor pressure. In a truck from the 1930s, the seals are not likely to be good enough to contain the gasoline vapor, and the vapor will leak out into space, which will lower the pressure around the liquid gasoline, which will evaporate more of it into vapor to keep it in equilibrium, thus creating a chain of causality that would lead to the truck not even having any gasoline left after 400 years. If this doesn't make sense so far, let's look at a liquid we have observed in space. A 2016 Forbes article asks the question of whether water would freeze or boil in space. The answer is weirdly, both. As pressure decreases, so do boiling points. So in the vacuum of space, where pressure is effectively zero, water boils into vapor almost instantly, but then turns to crystallized water vapor soon after that. This leads us to the battery. Based on what we just talked about with the gasoline, it's very probable that a similar fate would befall the battery. The liquid part of car batteries are sulfuric acid and our old friend water. There are vents in these batteries, so it's very probable that the liquids in the battery just won't be there anymore. Here on Earth, a car battery can freeze solid depending on the amount of charge in it. When a battery is fully discharged, the liquid is mostly just water and will freeze solid at around -10 Fahrenheit. A fully charged battery has more sulfuric acid and will take to -80 Fahrenheit to freeze. But space is much colder, and the battery on the truck is, in the best case scenario, a block of ice for quite a while after being beamed on board. Now, let's move on to a different type of science, that of amplitude-modulated radio signals. While we hear sometimes about how our radio emissions have been beamed into space for over 100 years now, it's a bit of a half-truth. While some amount of our terrestrial radio emissions do make it into space, AM signals are the least likely. The majority of the signal bounces off the ionosphere and is why they have such great terrestrial range. But that doesn't leave much to make it into space. Moreover, this AM signal is omnidirectional, meaning it's broadcasting its power equally in all directions. If this had been picked up by Voyager's instruments, I wouldn't question its magical ability to tease out this faint signal and clean it up. But we hear it from a basic 1930s AM truck radio, which at absolute best would sound like this. Science fiction doesn't have to always get advanced science right to be great, though it's nice when it at least gets basic science right so it doesn't completely destroy our suspension of disbelief. I hope you've enjoyed the debunking. Join us next time when we tackle the humble communicator and why it's unlikely to create a rock slide. Also, if you're new to the channel, check out our primary show ranking every live-action episode of the Star Trek franchise. I've been your host, Dustin Wing.